All of this capability of being able to deliver the data from one system to the other or to do the integration is being covered by the term data ops or data operations that's gaining ground. And that's one of the keywords that you're targeting in terms of the positioning of what you're building at Nexla. And so I'm wondering if you can give your version of what data ops involves and some of the elements that need to be implemented to be able to actually deliver on that promise.
We were one of the early ones in 2016, 2017 talking about data ops. Our thinking about operations was that, the purpose of operations is to bring scale. Not in terms of data volume necessarily, but in terms of how things are run, how are more people working with data, or are there more data sets in more applications. So we took that sort of point of view of operations when using the word operations along with data. So our approach to the operations aspect was that you have to have certain degree of automation, right? In how you connect with data, how you flow data, how multiple people use it together. That's how you'll scale your team, right? So those were the sort of core principles that we started with on the data operations side. The resulting application for the user was that, I need to integrate data, I need to prepare it, I need to monitor that. So we think of the operations as a layer on top of these fundamental data functions, right? That allows a team to scale.
In terms of the actual architectural and implementation details of Nexla and some of the ways that you're able to build these next sets, I'm wondering if you can give an overview of some of the technical aspects.
So the fundamental premise behind Nexla was, on one hand, you have a lot of variety of data, increasing complexity. On the other hand, you have a user who shouldn't have to write code, right? So we figured that in between, there has to be tech that can take all that variety of data, different systems, connectors, and so on, and present the data to the user in a useful fashion. And that was the next set, right? So these next sets, the way they start functioning is, first of all, they start with observing the data. So the connector is spitting the data out, and the next sets, that element is observing the data and it's figuring what is the schema, and it will get a schema from, the first set of records, but it'll continuously keep looking at it. So the first aspect is, what's the schema of the data? Infer that, observe that over time, determine if the schema is changing, evolving, or the data that is coming now is actually should be a new next set. So that's one aspect of the thing. The second aspect of the thing then is like, what time does data come? How much data do we see? Those are some of the metadata that we observe about that as well. Then when we go into the data itself, we say, the data has an attribute called price, and it has been changing like this. So we're computing characteristics of the data, right? So these are some of the elements that come in. The sort of going term for that is metadata intelligence. And, people are calling it as a data fabric architecture, but, those are all the terminologies. Let's stay on the tech itself. So that's what happens, and that sort of feeds into the concept of the next set, right? Now, the next set also knows where the data is coming from. So, for example, this record was line 500 in that file, for example, right? So that information is also being gathered, right? And then it starts to say, okay, I know enough about the data to present it to the user in a UI that they can look at. But at this time, it doesn't matter to the next set that the data came from a stream, or it came from an API, or it came from a file. It's immaterial where it came from. It can be presented to the user in a common interface. And then the next sets over top of that say, well, who can access it? What is the history? How has the schema changed over time? Which user has modified it? And then along with that, they keep documentation, right? Hey, what's the description of this next set? Has the user created an annotation for an attribute to say, this attribute is actually coming from a web form? So those are the other things that come in and become part of the next set. And then as the data is flowing through, the next sets are not doing anything. They're like an incomplete electronic circuit, right? So it's not flowing anything yet. It's observing, it's sampling, but nothing is flowing. Once you connect the next set to a data system, right, then it starts to materialize the data there. So you point an next set to a database, and it says, okay, it's going to be an ETL flow, let's say. Or if you want to get an API to the data, it can surface that, or wherever you want to use the data, it can now materialize, but it knows enough about the data to now convert the format, for example. It also knows enough about the data to now run some validations on it, right? This field should have been like this, or let the user define their validations. And then when it sees those validations fail, then it throws the data record into a quarantine area where it's a separate sort of processing that you can do. So the next set sits as this logical entity in the middle, and then sort of acts as the data router when you eventually end up using.
And then there's a complexity on the whole runtime aspect of this, right? How do you run a net set which might have trillions of records behind it, and also run a net set which might have few hundred records on the same system? How do you separate out your execution engines from a user who is waiting on the other side to receive a response within 100 millisecond versus user who is expecting a batch of data to be dropped in his data warehouse once in the night, right? So that itself is challenging. And you present the same interface to the user, but under the hood, you can have different execution engines running in parallel.
Yeah, but that's the execution part of it. And at the next level, you're just looking at it in the UI, you're making your decisions, you're designing stuff. And when it's done, then the execution knows like from all that information like what to do and which execution engine is right and all that stuff.
And so in terms of the actual technical details of executing on the plans that the Nexset generates, is that something that you're performing on behalf of the end user, where you have your own infrastructure and data platform architecture for being able to do all this processing? Or is this something where you provide the sort of orchestration and implementation layer, and then the customer has the actual underlying infrastructure that just executes on the plan that you generate for them?
So for the execution part, which is kind of the data backplane, if you will, the processing stuff, that is something that we provide as a SaaS hosted service, but we run multiple instances. There's an instance in Amazon, there's an instance in GCP, an instance in Europe. So depending on what you need with the data and where it needs to be processed, we provide that execution engine, which is all the scale up and scale down of the containers, the underlying, Kafka, Spark, real-time engines, whatever it needs. It's all packaged and included. But we also do allow our customers to run Nexla on their own. So, they may need this for high-value data on-premise, and that's not connected to the internet. So they can run this whole thing internally. So they can choose to run their own data backplane, and we provide them with, the necessary Terraform templates or, to execute and run that. The end execution is sort of distributed in a federated fashion.